Firstly, let's go to SAS. SAS uses batch programming, so we, in the input window, we would develop our SAS code. Firstly, we would build the data. We have a data statement that is defined. We name our data file, in this case, chapter 10. We describe, then assign names to the variables. We input the variety named V2, V4, V3, for example. We include a $sign to denote that these are alphanumeric values. We don't, SAS is very flexible. We don't have to use alphanumerics. We could just use, names, or numbers will work just fine. R is a little bit less friendly in that respect. Likewise, we have the block names. In this case, again, $, to denote the alphanumerics. If we only had numerical values, 1 through 3, we could label those block and exclude the $sign. Finally, the value yield. We will put this down here in the model. Data lines, we input our data, each experimental unit on a separate line, semicolon, and we have proc GLM, general linear model, is the procedure that we use for conducting analysis of variance. We begin by defining our classification variables. We simply have the class statement. We define our 2 classification variables in this data set then as variety and block. And our model statement then, yield is the response variable. Yield equals block by variety. You'll recall we were just talking about the linear additive model. The grand mean can be assumed, the experimental error can be assumed, and so we have 2 terms then that are included with the model statement in SAS that come directly from the linear additive model. As we develop more complex experimental designs with more terms, we will add more terms here into our model statement. We say run, and then this will submit to a computer, and we get this output. SAS is famously verbose in the output, and we get 4 subtables when really we only need to look at this bottom table here, the type 3 sums of squares. For the data is balanced, and the type 1 and the type 3 will be absolutely identical. So let's just focus here on the bottom table. We can see we have the 2 terms that were present in our model, both block and variety. SAS has calculated the degrees of freedom. It's calculated the sums of squares, and you'll recognize these numbers, the 9.78, the 6.63, the mean squares, and finally, importantly, our F value, the 5.53, and SAS has calculated the probability for that, 0.0367, less than 0.05, and so we can say that the variety effect was significant. Moving over to programming in R, R has a different syntax than SAS. The data would be, we use Notepad and we create a file. In this case, I've arbitrarily referred to this as week6.txt. It will have the variety names at the tops of the columns. And likewise, we can see here the varieties, the blocks, and the yield data. We would read the data file. So here we can read the data in week6.txt. We read it as a data table. and we assign it the name my data. So through the rest of the programming, we would call our data using the name defined here. We notice the hash symbol. Any text that occurs after the hash symbol is annotation that's excluded from the analysis. So we could exclude this statement here. This is a reminder to let you know that I've labeled the blocks here are labeled B1 as alphanumeric characters. This is quite important in R because R will, because we've used a alphanumeric character, R will use this as a classification variable. You remember in SAS we had to define the classification variables. We don't need to do this in R because R can infer this from the syntax of the variables themselves. If we did not have alphanumerics, we just had 1, 2, 3, 4, R would assume that these are continuous variables and we would get an erroneous analysis. Here's another way we can fix that. We'll learn later through the semester, but just bear in mind that R does not need, we do not need to define the class variables so long as we make sure that they are alphanumeric characters. Here I've simply used the command mydata and it R will print out the data that it read from the file week6.txt. Here I show two different ways that we can conduct an ANOVA. In this first command, we're using the AOV command. And we're generating a variable, AOV.out, using the AOV command. And in this place here, we see the essence of the linear, the essence of the linear additive model where we have yield, tilde is a function of the variety and block. Again, just like in SAS, here we see these are derived from the linear additive model. The grand mean and the experimental error are assumed in this case, and variety and block define the unique components of the I repeat then that variety and block are defined as the unique components of the this particular model. Again, here a hash, a note that to remind me to mention here that R is case specific. SAS is not. So in the data file, variety has an uppercase letter followed by lowercase. Block is uppercase followed by lowercase. Yield is uppercase followed by lowercase. R is absolutely specific that we have to use the same upper and lowercase letters when we're defining the model statement. If we do not, we'll get an error statement. If we had lowercase b in block, it would say data not found. We'll get an error statement. It can be quite frustrating. So just bear in mind, R is case specific. We can use the summary statement, summary for the AOV.out variable, and it will create the ANOVA table that we are familiar with. You can see the variety effect, the 6.63 you'll recognize, the block effect, 9.78 you'll recognize the residuals, the 5.5 F value, and the probability 0.03. So I show an alternative way. There's many of these software have different ways of generating output. So here we use the AOV command. In this case, we have a different option. We can use the linear, the LM, the linear model command. Create a nominal variable. In this case, it's called fit, where we create the variable fit using the LM command. And again, here we can see the same syntax for the general linear model that is incorporated into the statement here. Then we would run in this case, we run the ANOVA command, ANOVA fit, and it creates the analysis of variance table, the same analysis of variance table that we had above. Simply just two different ways of generating the same ANOVA table.